Again, I'm your humble community servant, Chris. We are live again from the Kingdom Games studio. I'm here with Brandon, our lead engineer. Do you want to introduce yourself again? But
Sure.
You know.
I'm the lead engineer here at Kingdom Games. So that means a lot of writing code, working with systems, helping artists and designers getting things done. Anything with builds or software versioning, plugins, all of that good stuff wrapped into one. Yeah.
Did you always work in games, or how'd you end up at Kingdom?
I've been making games professionally for 4 years. I've been my entire life kind of working on maps or mods. Never anything that's big, out in the community.
Right.
But I guess it's probably started with a game that I still have yet to work with someone who's played Warlords 2 Deluxe. It's kind of like an old turn-based game. I guess similar. Heroes of Might and Magic, I think, kind of took their mold and made it better. But they had a unit and map editor, kind of like earlier than Warcraft 2 Tides of Darkness, but similar, where you can paint terrain and water and stuff. And I remember waking up early in the morning in like first and second grade and making some of that. But
Wow.
I guess before working in games, I did some IT stuff while in school and a little bit of after school, but kind of knew I needed to get into games and wanted to. So
here you are, and you've been
Yep.
with Kingdom about 9 months, 8 months?
7 to 8 months.
Okay.
I forget the exact date, but and I've been working, like I said, about 4 years being paid to make games.
Yeah,
so.
which is awesome.
Yeah.
It's always nice when you can kind of go from hobbyist to professional.
Sure, yeah.
And then,
It's awesome that
it's
you
nice
can
to pay the bills.
Yeah, and get paid to get better at what you like to do.
Yeah.
That's the way I like to view it. So
Very cool. So, recently completed or working on the Unity 5 upgrade. How's that going?
It's going all right. There's been a number of hiccups. It seems like a lot of our shaders that we have aren't really compatible with Unity 5, so we kind of have to identify them, have the artist fix them, sometimes possibly find shaders that exist already and use them to make time go faster.
A lot of fixing pink, right?
Yeah,
A lot of fixing
it's
pink
I think
placeholder.
Magenta is the
Magenta. Oh, magenta.
yeah,
Okay.
sorry. So, I'm trying to think what else we've. Most of it hasn't been too bad. We updated all of our plugins. Some of our scenes, we had some terrain issues, and we finally figured that out today. That was kind of a pain. Lots of little things that aren't too obvious. We had some big issues at first. We had these crazy paper doll characters being rendered on top of everything, and some of our videos still aren't playing, but we've been making really good progress. And I think hopefully end of next week, we still want to do some optimization
Right.
too to get the frame rate a little bit better. Hopefully, by end of next week, we should be fully onto Unity 5 and ready to make a build.
That's exciting.
Yeah.
It's very exciting. So, it's a nice little preview for everyone out there. Unity 5 is coming. Dates TBD, but
Sure.
we'll get up with it. We are Kingdom Games ATX, of course. That is Kingdom Games Austin, Texas. You can find us on all of your favorite social media sites, which I'll have links to here. Kingdom Games ATX on Twitter, Facebook, Instagram. Of course, 5 Guardians of David is the game on Steam, live right now. And we are providing some development updates and all sorts of fun stuff over the next coming months, coming year. Expect really cool stuff that you may have heard previews on podcasts or interviews recently with DarkStation, InfoWars, and various other organizations. So this week we are here with Brandon, and I'm here to pick your brain about Codebase, because I did a couple years of Java in high school, and then realized when everyone said, oh, you can kind of know how to change a variable, but you're not very good at coding, so you should do web design. So I kind of went that route, the simpler route. So I kind of understand control structures and variables and stuff, but I'm always fascinated to see how that comes together to make a game.
Yeah.
Even simple stuff is more complex under the hood, right?
Sure.
There's There's no make a game button or make a character button. It's a little more complicated than that.
And really, Java is C# is what we use with Unity. You can use a couple languages with Unity, like they have their own language, Boo, and they also have JavaScript. But C# is, I think, the best for it. And really, Java and C# are pretty similar. Like C# is kind of Microsoft's answer to Java,
right.
But also a lot better, in my opinion. It depends what you're trying to do, what language you should use. But, if you know Java, I think you'd be able to pick up C# pretty
I said I took 2 years of Java. I didn't say I was good at it.
That's fair.
Yeah, I know what a while loop is, but
there you go.
Implementing anything beyond basic stuff, like I have problems with like calculator applications. I'm learning.
That's all right.
Yeah, I'm slow.
Start somewhere, right?
Yeah, very basic stuff.
Yeah.
So what is the basics of, like, let's say we wanted to make a game. What is the most basic thing? What's the first thing you would create?
Like from a code point of view?
Yeah.
Or just overall?
Tell me where you'd start. Dealer's choice. I'm your student here.
Okay. It clearly depends on the type of game you're going to make, because if you're going to make a Words with Friends, it's quite a bit different than if you're going to make an ARPG like Guardians of David. But I guess, I work on prototypes or my own projects. I would say generally you need some sort of game controller. Unity provides a lot of built-in methods like update, start, awake. But you normally want a main piece of code that kind of controls everything. Organization is pretty important, and I say that knowing that I have written a lot of code that is not organized, and a lot of things I say in theory I may not have applied as well as I should have, and it's often come back to bite me. But it's really nice to have like a centralized controller. In Kingdom, we actually use a few different ones, but for instance, we have like an area controller which contains all the data for the level, what characters we're going to spawn in at the beginning, kind of sets up a lot of things. But starting, you need some sort of piece that handles, like, we have all this content in the game, it needs to update, because if everything just kind of controls itself, it can be good, but you'll often run into instances where you're not exactly sure what is going to update before what, and not having that control can lead to weird situations where information is changed before it should be changed. Maybe an easy example would be like your camera. You generally want your camera to be the last thing that's moved, because everything else in the world needs to be done before the camera is moved, so that it matches up with that frame. So camera stuff will happen in the late update type of thing. If that makes sense.
Yeah, definitely. And when you say update, that's everything. So a game is structured as basically a stop motion comic, if you will, right? Like each frame has to be rendered for something to happen, whether that's movement or health or whatever. It all has to be rendered in each individual step.
Sure. Yeah, so generally, like, what you have is called the game loop, and essentially what it is you have your CPU and your GPU, and what happens is the CPU will run all of your code. And so when I say an update loop, it's kind of like everything that goes on, the movement of characters, the AI, all of that. CPU does all of its stuff, figures it out, and then it sends the GPU all the information of like vertexes, triangles, and all of that, and the GPU has to then render it, and sometimes the CPU will be waiting for the GPU. Oftentimes, depending on your game, you're more likely to be capped out by your GPU. And so like everything happens in the game, send that information to the GPU, and then it draws it, and then that's your loop, and that would be your frame. So if it takes 100 milliseconds, which would be a really long time to do that, you would get about 10 frames per second.
Okay.
So
we want faster.
Yeah, you want much faster. You want they say at least 30 or so is 24. I think is what is used for movies for.
Yeah, 24.
Best for the eye.
Yeah, and then 29.3 for TV, and now they've started to. I think they shifted that about 10 years ago now. They shifted to HD, which is 59.
Okay.
Yeah, and then Blu-ray I think is 60, and then that's audio's waves too. So that's why Blu-ray movies are like 10, 20 gigs because all the audio is uncompressed.
Sure.
Yeah. It's interesting stuff.
Nice.
I know some of the some of the stuff from the film perspective. So that's why this game stuff's actually kind of fascinating to me. So you have your pieces then, right? You have your players, so you have some systems set up. But what I learned that I thought was fascinating, if you put a player controller and then you build a map and then you drop the player controller when you run the game, if you don't set up collision, you just fall through the floor.
Oh, sure.
Like the game, like I never knew that games don't automatically do that. Because you would think logically, like if you put an apple on the table, the apple sits on the table. But
sure, yeah, it depends if you're going to be using the physics or not. So obviously on our player characters we use physics and we have gravity, and we don't use physics too much in our game. We do use it for ragdolls when you like crit kill an enemy.
Totally
there's been some pretty funny stuff, and actually with the Unity 5 upgrade we saw some hilariously creepy
I saw the wolves. I saw the bat wolves.
So, but some games you don't actually use physics, and the caveat with physics is that you're not always in complete control. Sometimes you'll notice in some of the bigger games that use physics. I know Gary's mod for Half-Life 2, right? People showed some crazy stuff of and then things are like flying and all of that, and really it can be hard to tune the mass and gravity values and all of that. So we use it in a limited fashion because we don't want any of that crazy stuff. And I think if you were part of the QA team before we released it, you would have seen that we had some pretty crazy physics stuff going on that we had to fix. So yeah, I mean,
it's a challenge with any realistic function. Like ragdolls were amazing. And I want to say like early 2000s when that really became popular, and then it got kind of silly. At some point, that became campy. Like it took like a couple years, and ragdoll almost became not extreme enough anymore. And they got more realistic with it.
Yeah, and in my personal opinion, I often try not to depend solely on the physics engines just because of those weird things that you'll experience. And really, like, if you don't need it, don't use it. In an ARPG kind of like ours, we don't really have jumping, we don't have a lot of that stuff. There's no, it's not like in a baseball game, if pitch is coming and the bat's going to hit it, it really makes a difference, where that's going to go for the ball. For us, it's, click, do a lot of ray casting and
and what is raycasting?
What is raycasting?
Yes, that's an interesting one.
It's pretty much what it sounds like. When you do, it's used for computer graphics for rendering and everything. So if you imagine, like, this is your camera, essentially you would shoot a ray through each pixel, and that's how the scenes are generally rendered. But you also use it for collision detection. So in our game, or Diablo, any of those ARPGs, you're moving the mouse around and you click somewhere. Well, how does the game know where you've clicked? So essentially it will take the camera place, and then you can find out where the mouse is on the screen, and then you would use some transforms to turn it into the world space. And essentially with these 2 points you can create a vector between them, and there's some fairly easy collision math you can do, which a lot of that is actually handled by Unity.
Oh, great.
In Unity, you can, anything that is a collider, they have box colliders, mesh colliders. So if you created a 3D model in Maya or 3ds Max, you can bring it in and use those triangles as a collider, and if the raycast hits it, it'll let you know. But the math behind it really isn't too complicated, but at the same time, if it's there's no point to reinvent the wheel,
Yeah, that makes sense. So that would be almost like a 1-to-1 if you could actually take a shadow of your 3D model and overlay it as your collision detection versus.
Yeah, and actually a lot of times what we do, if we want, mesh colliders can be kind of expensive. So for instance, if we have a character And we actually don't use mesh colliders for characters. Maybe I need a better example. Maybe for some level geometry like rocks or whatever. If we have a decently detailed rock, which seems kind of lame, like why do you want a super detailed rock? But let's go with it. It'll have maybe, let's say, 500 triangles and 500 verts or whatever. We would often then, the artist will then make a low poly mesh that we'll use for collision. So it's kind of like an estimate of the, it's approximation of the real mesh, but it has a lot less triangles.
Yeah, because it doesn't need the detail.
So it's a lot faster if you do that. Yeah, that answer your question?
Yes.
Kind of forgot what the question was.
It's all good. Well, that was ray casting, and that was actually very detailed and thorough.
Okay.
Very deep. I like that. So we have our characters,
Mm-hmm.
we have our player, we have our collision. Now we want to go somewhere. What does that look like on the back end? We want to get from point A to point B and do something.
Well, we handle it. There's two main cases, right? There is the player you are controlling with your clicks and the mouse, and then there's all the rest of the guys that are moved by AI. How much detail do we want?
We can paint in broad strokes, or we can get thorough.
Okay.
I'm willing to learn.
I'll try to give I won't get too into the detail. Essentially, we have a world. We have a lot of geometry, terrain, and then also buildings, anything.
Right.
And designers and artists, they go through the levels and they'll mark objects as walkable or not walkable.
Okay.
Essentially, walkable will be anything you can move on or a character can move on.
Right.
You can get a little more advanced than that. We'll stay out of it. But essentially, we use a third-party plugin because it wouldn't make a lot of sense for us to spend a lot of time making something that we could purchase for not much money at all, right? But the way it's done is it'll project. It'll actually do a lot of raycasts from the top. So if your geometry is down here, imagine something parallel up here, shooting down a bunch of rays, and it creates a grid. And so we talked about, our levels aren't necessarily just boxes, right? It can be weird curves or whatever. And so it uses a little bit of granularity, and it shoots the raycast down. If it hits something that's valid, it's like, okay, this is a good cell, right?
Right.
So that's all done in the engine, not during play. That's all set up, and we have these grids that are baked, and it has cells that are walkable or not walkable. And then when you play the game, if you are the controlled character, we're mostly not really using real pathing. There are some instances where we do, but essentially it's just like, if your mouse is here, move him towards the mouse. That's pretty common with ARPGs. Right. If you're going to do something like StarCraft, you can click anywhere on the mini-map, and your dude will run across the entire map with this, creates this path.
Right.
And we use a similar thing for our AI or our followers. Essentially, you know where they want to go. So for an enemy trying to attack you, obviously, like the character's position would be like the target position.
Right.
And they say, enemies like, oh, I'm right here at, let's say, 0-0, and I want to go to, cell 28-7 or whatever. It's done asynchronously in the fact that if a character wants to move, the code is run independently of the frame. It's kind of like a high-level explanation of it. It's similar to threading, but it doesn't actually use like true threads. And really, it uses we either use A star or like a optimized version that can lead to sometimes bad-looking results. It's called jump point search. A star is pretty standard that you'll see. But a lot of times you're going to want to... hacks is probably the wrong word, but you don't want to rely solely on something like A-star because it can be slow. And, for instance, if you have 20 guys, on screen all trying to repath all the time, it could slow things down. So oftentimes if a character is close to his target and you're moving, you don't necessarily have to do like an A-star repathing. You can just kind of point them in the direction you want to go and send them along that way. So if you were a character moving like this, you would see them follow you like that.
Right.
And it's really cheap to say, here's a point, draw a line and follow that line.
Right.
Whereas A-star is it's a pathing algorithm that builds a path based on the most available shortest distance. I won't get too much into that because that's a whole lecture of itself. But yeah, so we have discretized grids. We make a request and say, I'm here. This is where I want to go. Give me a path, and then the code goes and gives you the path.
I like that. I like that. So it's that simple. Okay. Exactly. So do you put that in the mic or?
No, it's just the sound the machine makes.
Okay, perfect. Yeah. Okay, awesome. So we have our players, we have our characters, we have our grid. They can move now. So let's jump 20 steps ahead to polish. I'd like to know, because I think this is actually a fascinating conversation that we've kind of had before. It's about optimization. So like, you have all the pieces. What can you do then to make it run as succinctly, quickly, cleanly as possible? Like, what kind of changes do you make? What kind of decisions are made on that front?
Sure. I guess the first thing you would do is actually profile your game and see what is taking a long time. So we talked about there's the CPU and the GPU, and Unity has a really nice tool for profiling, and most engines are going to have a nice tool. If you do iPhone development, Xcode has some nice tools for it as well. But essentially, you want to see what is taking so long. You can try optimizing without doing that, but then you're kind of like doing it blindly. Obviously, like reducing triangles, reducing verts, reducing draw calls will help you, but you want to look into the profile. And so you want to see if you're CPU bound or GPU bound.
Right.
So essentially, like, if the CPU takes 45 milliseconds to complete and the GPU is taking 60 milliseconds to complete, it's going to take 60 milliseconds for your entire frame. A little bit more than that just because of the overhead of going between the CPU and GPU, which it's not much. But once you have identified where your problem is, so let's say in that example, the GPU is what's bounding your frame rate, right?
Okay.
So improving code performance isn't going to improve the frame rate for the user because it's still waiting that much time for the GPU.
Oh, okay, that makes sense.
So, for instance, in the GPU, you've seen that's what's taking a long time. Like, the CPU is essentially finishing its cycle first and then waiting for the GPU to finish before the frame is over. And so you'll want to look and see what is taking the GPU a long time. You'll hear draw calls a lot, and it's essentially you can batch, like, there's a lot of optimization that goes in, but for instance, if we have a rock that's used, the same rock all over the place in a level, you don't want to like have 20 different draw calls for each of the separate rocks. Essentially, they're all referencing the same object. It's all the same data. It's just its position is different. It'll batch those all and draw them at once. So there's a lot of things you can do to improve performance. I think when we were profiling our game, we noticed that we use a see-through shader. So essentially, if your character is here, the camera's here, and there's an object in between, like, you want to be able to see your character, right? And so we used a shader to kind of draw a hole around the character and anybody that's behind it.
Wow.
And we noticed that was taking about a quarter to a third of the GPU.
Wow.
Yeah, and removing that, will give you 8 to 10 frames right there. So you really want to profile and identify the types of things. Depending on the game, it can be all sorts of stuff. Lots of different materials will generally cause GPU to take longer. And then I guess we want to talk about the flip side is if the CPU is the bounding issue. So like the GPU doesn't take as much time as the CPU, and in that case, you're going to want to look at your code and see, you know, what's taking a long time. And you know, if you write, you might have a mistake where, you know, you've infinite loop or something like that. Obviously, infinite loop wouldn't. There wouldn't be an end to that frame, right? Maybe I need a better example. And I guess I'm also talking about CPU optimization. There's also memory optimization.
Okay.
But what I've been talking about has been purely, you know, time-based, what affects your frame rate.
Right.
And there's also, you know, memory considerations of, you know, a computer only has so much RAM, only have so much loaded in at one time. How do you deal with that? So, yeah. I could probably talk a lot about optimization.
That's awesome. That's actually really informative. That's fascinating. I wish I had more to add to it, but I don't. That was awesome. So, we have our game. We've talked about optimizing it. So let's say we have this game, and now we want to turn into an ARPG. What kind of unique challenges are we going to face there? From camera to XP? Like, what is kind of the crux of what makes an ARPG an ARPG from the back end?
From the back end?
Yeah.
I would say that it's maybe not as different from a lot of games. I think a lot of games are going to share a lot of the same mechanics. There are, I would say it's more design and art challenges.
Okay.
Right? So, like, if you have an isometric viewpoint, obviously art has to be set up in a way that looks good from that viewpoint. And you know, you can make some gains because if you know a camera's only going to be looking right here, you can have an object right here that's only really an object on this side, and if you actually turn it around, it's nothing. It's cut off, you know.
Yeah.
And then in terms of, you know, for ARPG, I think people most expect loot and combat. From an engineering perspective, I'm trying to think
How about the character swapping? That's very unique. That's
sure.
got to be challenging, right? I mean, what's it like to put that together? Is that easier than expected?
Yeah, you know, a lot of things are, maybe not a lot of things, but oftentimes, you know, systems aren't that hard to implement, but it's hard to implement it and be fun, if that makes sense.
Yes, definitely.
Like, you can make a character move around and attack fairly easily, and really getting that back-end part in isn't too hard. It's more providing the tools for the designers and artists to be able to make it fun. You know, like exposing certain values so they could speed up things, or even just for combat, we obviously have a lot of abilities, right? And so we have to create tools so that designers can put together all sorts of different abilities that do different things. You know, we have traps and projectiles and AoE, some that are like farther away, some that are around your character, and writing those tools for the designers or artists is probably where the challenge, so a game can actually be fun. You know, like I can go home and open up Unity, start a new project, and get some basic mechanics in, but I don't think anybody would want to actually play that game, you know? You know, if you look at a lot of games, you can kind of say, like, these are the same mechanics, just skinned differently, right?
Yeah.
And so, you know, in some regards, my job is easier than designers because, you know, I can make something and say, well, here you go. You know, this is what you asked for. Now you go make it fun. You know.
Yeah.
So.
I rigged the camera up, and I've got placeholder squares, or I've got your character able to move, and he collides and hear enemies, but you have to come up with the impact or the feel or the game, so to speak.
It's easy to quantify if code is good or working. It's a lot harder to quantify if like a game is fun or design is well done, you know. I think that's kind of the holy grail that people are still looking for in games. It's just what is fun and how do you achieve fun, you know?
Yeah, that makes sense. And a big part of that is, I think, AI, which is something you've touched on. But would you mind going a little more in depth of that? So you have your character,
Sure.
you have your AI, and we talked about AI pathfinding, but what else goes into AI? Is it as simple as, hey, here's the character, get him? Or is it more complicated?
Yes and no. It varies on the game, obviously.
Mm-hmm.
Specifically in Guardians of David, we essentially, each unit contains a brain, and we visualize the brain in our engine, and it's essentially like a node system based on logical values. So what happens is you need to say we don't want the AI running every frame because that would get more expensive than we want it. So I think we have it 10 times a second essentially be running. So every 10th of a second we tell each of their AIs to run, and there's a logical tree that it runs through, and I'm going to try to explain this in a way that makes sense. For instance, on an enemy, I think the first node, it's like an essentially logical and it has a bunch of children underneath. And it's a basic state check to say, like, am I stunned? You know, am I dead? Right? Because, you know, if someone's dead, you don't want them to be moving around.
Yeah.
All of that, right? And so what happens is we say run, and it's possible that if last time the AI completed, it'll start over at the beginning of the tree, and it'll go through the state checks, and then after the state checks, it's gonna be like, is combat occurring right now? And then if combat is occurring, it's gonna say, okay, what targets are there? What target should be mine? It gets a little more complicated with how it's actually implemented, but on a high level, you know, it's like there's a bunch of guys. What criteria do I have for targeting? Okay, here's my target. Now move to the target and attack. And then some of those states along the way, like the movement one, for instance, that is going to stay in that node. It's not going to start the whole tree over every time. Mm-hmm. It's going to be there. And so if you are into AI, it would be known as a behavior tree.
Right.
As a, you know, there's other ways you can do AI, but we use a behavior tree. And so when you're moving, obviously, like, if they have a target, that target can move. Mm-hmm. So it's not just like move to this spot. Every time the AI updates, it's checking, has the player moved far enough away that I need to repath to them. So visually, it's a tree with a bunch of things connected based on ands and ors, and you know, designers can set weights and variables, and, you know, it's a nice system where we can write custom code for anything you want.
Right.
I guess.
Awesome. That's cool.
Maybe not anything.
Anything is possible with code.
Yeah.
We are almost out of time here today, so if you have any questions, please drop them in the chat for Brandon, our lead engineer. I'd like to take it a little lighter. So, do you have time to play games lately, or is it just all work? Like, what are you playing lately?
I like. I'm a big JRPG fan, and I don't know if this is embarrassing or not, but I've been playing Yokai Watch for my 3DS, and I've actually been trying to beat that because tomorrow Mario & Luigi Paper Jam comes out. But I play games. I mean, occasionally I'll pull up Battlefront or something. Yeah. You know, I was actually playing Xenoblade Chronicles X for a while. Have you played that game?
No, Bill was telling me I should play it. Yeah, he's
telling me Xenoblade Chronicles for Wii is an awesome game, and I liked it. And Xenoblade Chronicles X is, it's good, but, you know, for being a JRPG, the story is pretty lackluster, really? Especially compared to Chronicles. You know, I've played like 28 hours, so it's not like it's a